light is a beautiful thing, but what are its properties? Well, light is a wave, and only a wave. This can be proven through a process called diffraction. Diffraction is the bending of light. So, there you have it. Light is a wave, not a particle. Only a particle. Case closed. Toodles! Actually, light has certain properties that allow it to behave like a particle. This can be proven by Albert Einstein's work on the photoelectric effect. The photoelectric effect can be achieved by shining light of different frequencies at a metal with loose electrons on the surface. Sometimes, electrons are able to be liberated from the surface of the metal. When this experiment was first conducted, scientists soon realized that even the brightest beams of red light, or another low-frequency light, could not liberate any electrons from the surface of the metal at all, and even the dullest beams of blue light, or another high-frequency light, still gave the electrons enough energy to pop off the surface. So here we have a graph. On the x-axis we have the frequency of light, and on the y-axis we have energy of liberated electrons. Towards the lower side of this frequency spectrum, no electrons are being liberated from the surface. They may still be gaining some energy, but not enough to jump off the surface. After a certain frequency, this line begins to increase in a linear slope. This showed scientists that the energy that the electrons gained from the light was directly proportional to the light's frequency, not its brightness. Why? I was hired by an electrical company to do some research on the radiation emitted by black bodies. In my mathematical work, I assumed that light traveled in discrete packets called photons or quanta. They are more or less a particle. I thought that this was merely a mathematical trick, but maybe that's not the case. Planck thought that in his equations, his assuming that light traveled in discrete packets called quanta or photons was merely a mathematical trick, but thanks to Albert Einstein, we now know that that isn't the case. So I said to Professor Planck, "You're completely right. Light does in fact travel in discrete packets called quanta." Let me explain. The idea that light travels in packets, or that it has a particle-like quality, tells us that one photon is absorbed by one electron. When you increase the intensity of a low-frequency light, like a red light, all you are doing is adding more low-energy photons to the mix. This may increase the amount of energy in the light beam as a whole, but if one photon is only absorbed by one electron, then adding more low-energy photons to the beam of light by increasing its intensity won't really do very much. The thing is, we don't know. We know that light behaves like a particle because of, well, the photoelectric effect and other various experiments, and we know that light behaves like a wave because of certain behaviors like diffraction. How the wave-particle duality exists, or why it does, we just don't know, but what we do know is that one day, me and you will be a part of the next generation of physicists working together on the quest to discover the answer to the big why that is our universe. Spoiler alert, it's 42.